welcome to today's webinar. I'm going to kick off and get started right on time so we can get through this awesome fire release that we've just had happen. So today's webinar is on the structural fire design of timber buildings. It's our fourth webinar of our webinar series, and it will be presented today by Adam Jones for our Australia New Zealand region. All right. So I'm going to get into it. To begin, I'll kick off with our agenda. So I'll introduce myself properly in a little moment. I'll take us through some housekeeping just for the webinar. I'll talk to our latest releases briefly, and then we'll get straight into the design example presented by Adam. So to begin, I'm Corey Jones. I'm the Customer Success Manager here at CLT Toolbox. I also happen to be our presenter's wife. I'm loving the role that I play in this company. It's really awesome. I get to work with amazing people. Pictured here, we've got our software team at the end of their Ramadan celebrating all together. This was a very well-earned rest that they had straight after the US beta launch, so it was a massive push to app for them. So to begin with our housekeeping, I just want to bring to attention for this webinar, you've got two buttons. You've got one that's the group chat button. So feel free to say hello, have a chat, have a yarn. I know that Ringo likes to be very active in there, so you can say hello to him. And we'll also have the question button that you can ask. They're not to be confused, they're separate buttons. But if you want to put any questions you have throughout the webinar in that chat, Adam will be sure to get to all the questions at the end. As well, I just wanted to bring to your attention, we now have our full webinar recordings available on our community forum, so you can find them all there. But if you wanted to as well, we have very brief, small tutorial videos on our YouTube channels that hit more targeted specific points and are broken down into very small videos. So you can head to our YouTube channel if that's of interest to you too. So we've had a couple releases since our last webinar. So I just wanted to speak to the compression perp to grain release that we had in April. We had a few features come out here. We had the improved GLT compression perpendicular to grain calculator, the new CLT compression calculators for both point and continuous loads, enhanced support for edge, middle and corner loading cases, integrated screw reinforcements of our suppliers, some of our suppliers, design checks, and visual input feedback and expanded output clarity for real-world scenarios. But the reason that we're here today is to talk about the major fire design release that's just happened this morning. So it's very exciting. We've got new fire resistance calculators for CLT and GLT elements, multi-layered fire design models. We've got enhanced support for exposed versus protected scenarios. It incorporates the new Eurocode draft, analytical methods for resistance, integrity and insulation, real-time system builder for fire protection layers, supplier-specific charring integration now enabled. We've got visual failure feedback across scenarios, and we've also improved our user experience when the software is loading. So Adam's going to show you this live today and show you these new calculators, and we're really excited about this release. But we have to take a moment to thank all of our incredible partners. Without them, we wouldn't have this platform, and our engineers absolutely love having them on there. We're really, really excited to see some US and Canada suppliers and partners on the platform now, and we're equally as excited because there's more to come. So stay tuned on the supplier partner front. Before we kick off and get started, I just wanted to bring our attention to the challenges that engineers face when using the timber option and the reason our platform exists. And I wanted to speak to three hurdles specifically. So first hurdle being the complexity that comes with keeping supplier data up to date. There's a lot of time and energy that goes into that, the availability and variability of this detail, and as well keeping codes current. And a second hurdle that engineers face being reinventing the wheel by building their own spreadsheets and spending the hours of improving these spreadsheets. And the third hurdle being that faced at university, there's a little bit of a gap in education when it comes to timber. So these are hurdles that engineers face when going for the timber option rather than the status quo, and this is why our platform exists and the hurdles we hope to endeavour to solve for. So we're CLT Toolbox. We build tools to enable a profitable design of timber buildings, and this is who we are, and you'll get to jump into it in further detail today. So without further ado, I'm going to hand over to Adam, and we're going to get kick-started on the presentation of structural fire design of timber buildings. Over to you, Adam.
Thank you, Corey, and good morning, everybody, and thank you for sharing your time with us today. We're really excited to cover a really interesting topic, structural fire design of timber buildings. So there's a lot to get through. So what we're going to be covering today is an overview of fire design of timber buildings at the higher level. Then we're going to zoom in closer on structural fire design itself and some of the latest methods that are coming out and are available. Also code compliance. I know there's people from other regions right now joining the call, but we'll be focusing a bit on the NCC, but the ideas of deemed to satisfy and performance solutions are common across the globe essentially. And then we're going to do a few worked examples doing a fire design of a glulam member, but also a CLT member. All right, so before we get into it, I think it's always good to start at the very high level, some of the topics and the breadth of topics that come up. And a lot of these, or most of these, we're not addressing in detail today. So when it comes to structural fire design of timber buildings, you got to think sometimes about the levels of exposed timber and added fuel. So do you have multiple surfaces exposed onto each other, and how does that add fuel to the fire? Travelling fires for open plan offices is under research, and sometimes the testing doesn't cover the cases of open plan offices. There's consideration to life safety and firefighting intervention strategies. Reliable encapsulation matters. So when we show you encapsulation today, what about the fixings? Are they connecting and not the bottleneck to failure? What about after the FRL, the continuing decay and smouldering? What about standard fire tests are the basis of testing, but sometimes parametric testing represents the real fire curve. Glue line integrity, we're going to cover this a little bit today, but may lead to secondary flashover. Self-extinguishment. What about sprinkler reliability and redundancy? What about compartmentalization strategy? So there's a lot of things we're not covering today. I didn't dive into any of them, but there are some incredible resources out there which do cover some of these topics, and it's not limited to those on the screen. But if I had to pick one, the Bible of fire engineering would be the Fire Safe Use of Wood Buildings. It's an incredible compilation of world-leading experts on the topic of structural fire design. And Andy Buchanan, who'd be a familiar name to a lot of people on this call, was helped lead the research essentially. But other ones, so industry bodies provide extra research. So Wood Solutions has got a lot of fire engineering guides, but their 37 range really gives good detail on a DTS approach. And then there's different research around the world, like a lot of the glue line integrity and exposed timber, and a lot of that was done by Rise, and it's not limited to these. But I'd like to start here just to first make the point that the green tick of CLT Toolbox, or the green tick of a structural design for adequacy, is only partial scope when it comes to fire engineering. And it's always good to consult and collaborate with a fire engineer in order to get the full picture of what's happening. All right, so with that context, really important context set, now we're going to focus on the green tick of approval when it comes to just structural fire design more broadly. So when you think about fire design and the basics, I think understanding how to get a campfire going is something we can all relate to, and also gives us a good understanding of how fire engineering can happen for buildings. So if you think about it, we've got our own little wood heater. If you don't let any oxygen into it, it's not going to start the fire. So ventilation, how much oxygen is getting into it. Or if you think about how a fire develops, if you got kindling in the fire, that might burn through. So same like your furniture inside the building or something like that. But then if you got one log, maybe that log catches fire for a little bit, but the fire might go out itself, and that self-extinguishment might be a real thing. But then if you think about it, if you got multiple logs on the fire that catch fire, and you can have re-radiation of 2 or 3 logs onto each other, then you have a self-contained fire. And if you think about our buildings, like you might have a beam re-radiating onto a wall, or a wall onto a floor, and multiple exposed members have that interaction on top of each other. But there are certain ways you can design that out and make self-extinguishment more likely. So if you look at the chemical reaction, what happens is as you heat up the wood, there's a certain period where it dries up, so the moisture content is completely eliminated from the timber. Funnily enough, that is a piece of variability that's in fire tests as well that not always covered. And then from there, the decomposition begins at 150 degrees, and then the pyrolysis chemical reaction has a self-contained, a self-reinforcing reaction where the chemical reaction releases more heat, which releases which makes the reaction keep going, which is more load and so forth. So if you think about how the fire basics occurs, you might have the initial flashover and the ignition. So then from that, the fire might reduce and die down, and over a certain time, it might go out. But when it comes to timber, you might have an uncharred layer fall off, which might be related to glues, which we'll cover today, which may increase the a secondary flashover occurring. Or if there's actually multiple surfaces radiating onto each other, like I mentioned before, you might have a continuous reaction. So there's a few variabilities there, and again, a standard fire test looks a little bit different to this curve compared to, say, a parametric fire test. But as always, in terms of the basics, as a fire passes through, you can see here, it is true that it burns at a predictable rate if you know the different variables that go into it, and we're going to be covering that today based on the latest methods. But after a flashover, you can see there are basically timber left standing after, say, a bushfire, which we know all about in Australia. All right, so looking at the building code. So around the world right now, there is a good trend towards supporting timber buildings and an increase in the overall heights that are allowed from a global compliance point of view. Some countries are more lenient, some countries are more strict, sometimes for good reasons, sometimes for just perception only type reasons. But every code, it breaks down in this instance. Firstly, you've got what are the primary goals that we're trying to achieve with our design? And then underneath that, you've got objectives, and then you've got performance requirements. So the goals are obvious sometimes, like life safety. Can you actually have firefighting intervention? Secondary might be controlling property loss and financial damage and everything like that. And then underneath that, you've got an acceptable solution, like a deemed to satisfy or a performance-based design. So if you think about the third curve, before we get into DTS and performance, you got performance requirements. So to achieve those overall goals, like I mentioned before, some of the objectives of design might be you want it to stand long enough for life safety and fire crew intervention. You want to contain fire spread. You want to have thermal protection so the fire, again, doesn't spread as well. Prevent structural collapse, of course, protection of openings, safe egress, and so forth. And to achieve some of those objectives, there are performance requirements. So in all codes, or basically all codes, there's two pathways. One is a cookbook approach, like the deemed to satisfy solution. So if I'm going out there and getting Marley spoon and following a recipe, I don't need to be much of a good chef. All I need to do is follow the recipe, and I end up with a good meal that tastes pretty good and achieves the requirements of a tasty meal that, you might want it to be nutritious or something like that. And you can do it. You don't need to be a chef to do that. And that's what a DTS solution is. It's a cookbook approach to achieve performance requirements. Or you might hire a chef. If I get a personalized chef coming in, they can actually go nuts and do certain other pathways to achieve the objectives of a nice, tasty, nutritious meal. So with that, the performance solution, that's the same when it comes to fire engineering and acoustic design. And that way you can actually achieve more flexibility in the outcomes, particularly when it comes to exposed timber. So there's three different things. So performance requirements can be met by, and the typical way of justifying how you can achieve the requirements, there's three definitions that occur. So one is structural adequacy. That is related to structural performance. So does it remain structurally intact for the certain time period that you're trying to chase there? Second is integrity. Is the element still preventing fire from going from one compartment to the next, or hot gases? And then insulation is the temperature of the non-fire side below a certain temperature, again, to prevent the spread of fire. And if you look at different elements that go into a building, each one of these might have different goals. So if you've got a load-bearing wall separating two apartments, you want it to stand the whole time, but you also want to protect the fire from spreading to the adjacent apartment. If you're a column, you're obviously not separating anything, so it's just the adequacy that you're after. If you're a door, it's not carrying any load, so it's just integrity in insulation. So as you go through different building types, you've got different levels of risk, which require a different level of resistance that achieve those three criteria I mentioned before. So as you go taller in height, obviously you got higher risk, different types of occupancy, different types of use, and different types of fire load meaning you've actually got to achieve difference. And the way that's shown in the National Construction Code of Australia is type A, B, or C construction. And type C is where you're a little bit more loose. You can, it's really easy to expose your timber in that scenario, through to type A, where you've actually got to take it a lot more seriously. So how do you achieve the FRL within buildings, the building code? So if you look at it, this is actually found in Schedule 5 of the building code, and there's different ways you can achieve the FRL for different building products. So you can see here in Part A, you've got products like masonry and concrete, and you can just basically read it and determine what the FRL is, and it's quite straightforward for those materials. But you can see the timber isn't mentioned there, so CLT or GLT. Schedule 5 Part B, then other way to find out what the FRL is of a building product, you can always, and this gives you full flexibility, do a standard fire test with an accredited testing laboratory. So this could be Warrington Fire or CSIRO or something. And if they say it's great for the FRL, then they're the leading authority in that sense. So that's Part B from a single fire test. Part C lets you say, all right, we can extrapolate or interpolate a little bit. But again, that judgment needs to be made by the accredited testing laboratory. Part D is different. This actually gives you AS1720 Part 4, which is the building code, the structural design standard for timber elements. And Part 4 is about the fire resistance. So that is a pathway you can take for timber. And with that, there are certain requirements that need to be met. Number one, for manufacturing standards. So you can see here, if you meet these manufacturing standards of glulam, of LVL, plywood, and you meet the standards of structural adhesive performance, then you're sweet to actually go down that building code route. So when it comes to timber elements, for anything, you can do Part B or C, Part D when it comes to A1720 Part 4. But this is important to note, this is all about a deemed to satisfy FRL determination in the cookbook approach. But the reality is that the deemed to satisfy the cookbook approach, it may or may not be flexible enough. And the reality is most of the time a performance solution is taken, because when it comes to the structural fire design of buildings, to actually have some of these met, and I'll talk more about this in a second, it is always preferred, but it is sometimes unavoidable to fall in a performance solution. So with that, the most important thing is to have better analytical methods and to make it available and easier for engineers to use this. And the other point is, every time you go to performance solution, you are relying on expert judgment. So with that, an expert needs to become an expert one way or another to know what they're doing, because they're taking on the judgment at the end of the day, and they're being the chef coming in to cook a meal instead of the taking a cookbook approach. So when it comes to the basics, there are different fire design guides of CLT, particularly because it's a little bit more hairy, you could say, compared to standard timber elements. And here we recommend going to our partners' design guides to understand how that specific supplier works from a fire point of view. But what you'll notice is there is some variability in what's in these design guides. So some suppliers, they might publish span tables, and that is by a NATA accredited testing laboratory, which is great. That might be preferable. And the thing is, that might only be for simply supported or two span equal, but for your building, you might be outside of those scopes. Some suppliers just publish char rates, and some don't, and some publish nothing at all. So the idea is, I think, where you can find a DTS pathway, this is always preferred and will be the first tick of approval from your building surveyor. On the other hand, our app, which we'll show you later, this does help a lot and give you the tooling and hopefully engineering judgment, which we aim to get to actually help cover you when the performance solution approaches. And again, always speak directly with the supply chain, and I'd say with the fire engineer as well, to get it. And before we keep going, a few other considerations to think about. So think about a connection detail with a glulam beam and a CLT floor. You've got different compliance pathways for both. There's different char models available and how they work. We're going to cover that later today. Or if you think about a connection, there's different things going on. What about gaps between the connection? Can the fire actually approach the metal connectors prior? And how do you deal with those gaps? How much embedment? So in this instance, timber's protecting the actual connection. 5, what about steel versus timber behavior? Steel conducts heat, meaning the pyrolysis chemical reaction may begin prematurely as the steel heats up. And if your fixings go to the middle of timber, your charring rate might be at a certain point, but the steel might actually accelerate it. Or also penetrations. What about your penetrations? And usually there is a standard set of penetration details from the supply chain that are tested that you can get to. And what you don't want to do is doing a non-standard penetration for your mechanical services or something like that. And then that could be a bottleneck for a new fire test, where speaking to the supply chain up front, you'll know what penetration tests are available and, doing it within what they've got from a compliance point of view, because a fire test can be a bottleneck to a project and holding it up and everything like that. All right, now we're going to move into structural fire design theory. So just the high level basics and this is for an engineering audience. So number one, if we're looking at a glue lamp section, quite simply, work out the reduced section. So you might have a char model to find out what that reduced section size is. You can have new engineering properties to design with, and then you can have new loading combinations that are available for the reduced load for the fire combination or for the fire scenario. And then you design all of this together for the fire scenario. From a structural point of view, it's not that different. And once you know end to end. So if you look closer to AS1720 Part 4 as a method, as I briefly mentioned before, this is focusing specifically on adequacy as an alternative to AS1530 Part 4 fire testing. And that's assuming that you've got a few of the requirements that have been met. So in this, it does give you an opportunity to work out a char rate based on the density, which is different for an unprotected versus initially protected timber. And then you can work out the depth of char and reduce it from the initial fire section to then actually perform the design. When it comes to Eurocode, there's two methods available. You've got current Eurocode and you've got the new draft Eurocode, which we're also going to be touching on today. Reduced cross-section method, which is the most similar to what I mentioned before, AS1720 Part 4, or reduced properties method, more based on reducing the engineering properties value by a certain percentage. So similar to before, looks very similar in the unprotected and protected case to work out the depth of char, and then you go through the same process. So that's for a solid timber element, and we're going to be able to actually run through some worked examples of everything there. But CLT is maybe where it gets a bit more interesting and where there's more, I guess, context to learn about, and there's more meat to learn about as well. So if you think about in Europe, there's basically there's traditionally two methods. Now, I'm not going to try and pronounce the O, but au norm, it's the Austrian National Annex. That's one approach, and that's, think about the heartland of CLT globally, where you've got Haslacker, you've got Binderholz, you've got KLH, you've got some really big CLT suppliers there. Hence, it's no surprise that the Austrian National Annex is quite well developed relative to the existing Eurocode. And that's one approach we're going to show you in a second. You got obviously the existing Eurocode, and then you got the second generation of the draft Eurocode. And this actually brings in a lot of the research over the years and does introduce CLT into a design. So the Austrian National Annex, if you went down that path, it gives you a uniform char rate based on softwood. It's the reduced cross-section method, and it gives you a fixed zero strength layer and so forth. But the new Eurocode, which we're going to talk a little bit about today as well, and it's a draft method, so we could just go on about things that, and us at CLT Toolbox, we're going to give you the opportunity to choose between both, so you're on the latest, but you can also choose what's robust as anything else matures and as the new Eurocode eventually gets published. But it's like a little mature engineer on Christmas Day giving gifts from Santa, I think. If you're really interested in this sort of stuff and analytical methods that give you more tools to actually design more interesting scenarios, I think it's important for two reasons. Like, number one, whenever there's a gap in analytical methods, it means you need to do more and more fire tests, and sometimes they're unnecessary and they add a lot of costs to the timber option. So a good analytical method may reduce the reliance on fire testing. And number two, I didn't know what I was going to say number two when I said two reasons, but it's just a lot of fun and exciting. So some of the new things, connections in fire design. So what about, say, if you got a connection detail under fire, what happens to a screw? Insulation and integrity, it's explicitly mentioned, and you can actually calculate for these now. There's obviously CLT included, and it gives you pathways for using parametric fire design approaches. But when it comes to CLT, there are different, a layered approach now in the draft Eurocode, which wasn't on the previous Eurocode for CLT. And there's different phases that occur inside the fire. So if you think about the x-axis, you've got time as the timber burns, and then in the y-axis, you've got the reduction in the actual section that's left over. So if you think about this interesting scenario, there's a lot going on. So if we go back to what is the char rate of CLT, well, it depends. It depends on a lot of things. You can see here in phase 0, you might have a protection layer. Let's say if you've got plasterboard or something, that's still remaining. But then you've got a point of TCH, so char. That's where the temperature underneath the plasterboard is above above a certain temperature to start the fire chemical reaction. So it burns at a reduced rate. Then following that, TFP, that's a failure of the protection. You got a faster charring rate here because you got a fresh unexposed layer. Then following that, you've got an insulation layer that builds up at about 25 millimeters. So it slows down the charring rate back to the notional charring rate. And then if your glue line is maybe not maintained, again, you get a faster char rate and so forth. So, you know, if you think about all the variables and you get an understanding, you can understand intuitively how it all works. So some of the new things in the way this is covered, you've got the notional char rate divided by, multiplied by different design factors, and there's different factors that are introduced now. So for example, you've got now a gap factor, and when you install anything on site, you do have construction tolerances. You might install at a certain moisture content and the moisture dispels during service, creating gaps, all reasons why you might have gaps. And now the gaps actually increase the actual char rate and actually suggest a two-dimensional charring above a certain char rate. So that's multiplied, say, by 1.2 or a 20% increase. What about phase 2? So you can see phase 2, post-protection. It gives you numbers here, and it's different if your protection is plasterboard, fiberboard, or mineral wool, for example. So K2 is a dynamic value. Then you got K3, which is this post-protection phase, which is a faster. It gives you a faster rate for CLT versus a vertical member like CLT. So that increases by double, as you can see here for a floor. But if that's a wall, it's actually going to reduce not as much. And K4 is a consolidation factor about 1. So it's similar to the initial char rate as well. Other things, so zero strength layer AS1720 part 4 is a flat number. So does Eurocode, so does Austrian National Annex. But the draft Eurocode, this represents a different scenarios based on, are you on the tension side or the compression side? Are you protected or initially unprotected? That's going to change your zero strength layer. So that's basically a heat affected layer that you mine off, you take off for the final design. But also gives these little interesting footnotes that were quite interesting to wire in from a software point of view. But, you know, at A, so you can see here, you still need to reduce the final D effective in the following layer in the X direction by a minimum of 2 millimeters. So you can see here, as the timber burns through, you have to skip the adjacent layer plus 2 millimeters, for example, in certain scenarios. What about glue line integrity? That's another thing that's explicitly mentioned really well in the new code. And then I think most exciting from my perspective is a multi-layered protection approach. So it now does let you actually put inputs for a mineral wool or a plasterboard and actually a different build-up. And if you think about previously, one of the biggest bottlenecks is the multidisciplinary overlap between structural design, fire engineering, and acoustics. And sometimes it's very disjointed. So having the ability to flexibly do actually a build-up means you can actually get the acoustic information and fire information and structural information in the same hit. So I didn't make this on II. No, just kidding. But it's like, I don't know why I had Quidditch in my mind, but they're all on the same team and behaving well. And and one of the bottlenecks can be released from a cross-disciplinary point of view. With that said, now we can actually do it a worked example. So actually, before I go there, this worked example, we have 3 webinars on this exact example. So we go very deep on the design of a post and beam office building, and this worked example will extend upon that. So in this case, we had a structural grid of say 9 meters by 9 by 6 meters. So you can get double span CLT floors. And for this, I think we previously had a 240 millimeter Timberlink panel with an FRL for 120 minutes. And When we did the design from an ambient point of view, so the non-fire point of view, it was governing, of course, by vibration on a 240 mil panel. So now we're going to find out what governs the design. Is it fire or is it vibration? So this was just released in the app about 1 hour ago, actually. It's the most recent release. So you can see here, you've now got a new fire design option for floors, a new fire design option for walls, same for columns, and same for beams. So I'm going to, right now, fire up the CLT floor fire. And maybe I'll do a quick overview. So if you're new to the app, you can see here, floors, walls, beams, columns, your stud design, which is about to be released as well, connection design, screws, large dowels and bolts, moment connections coming, and connection details and so forth. So, and Corey is going to share at the end how everyone here can get free pro access for the month of May. So if we go to a floor fire design, for scope, we can go a personal or an enterprise account. So for enterprise, you can actually save it in a company one, which everyone can see. So I'm going to save this in our first webinar. And let's call it for one fire scenario and let it load up. So a lot of today's webinar, I'm going to hopefully cover in a certain way. So a few of the most recent releases, you can see it improves loading here. It's a skeleton type loading because people started clicking things prior to it loading. So that's a new release. And you can see here on the right-hand side, we now have a summary button here, which as you're doing inputs, know if it's working or not. All right, so what you're looking at here is a new cross-section of the CLT. You can see what's happening. You've got a plasterboard here as a default input. You've got, it fails at this certain period, and then it burns through for 30 minutes. And then you've got this hatch here, which indicates the zero strength layer. And right now we're designing for 5-layer, 135 millimeters based on the manually input buttons chosen. But instead, we're going to go back to our Timberlink panel, and we're going to go to our 7-layer 240. And you can see here, we've got a 7-layer design for 215 millimeters. So if you move through here, there's different options. So we do have the Austrian National Annex as the fire option. We've got the draft Eurocode, or you got a standard fire test. And that is, if you do a real world fire test, you can just input some of those values as well. So, and again, with everything, you've got the more information drop downs, which gives you some guidance on when you might choose both. So for us, as I said, the Austrian National Annex is different to the draft Eurocode. So if we input the draft Eurocode, you're going to see a difference in the zero strength layers available. So for us, we're going to do an FRL of 120 minutes, and the dynamic image will populate. And you can see now it's starting to end up with 3 layers of 96 millimeters. With this, we're going to do manual input for the char rate. So right now we haven't wired up all what the suppliers want us to input, but for the moment you can manually input the char rate at say 0.7 millimeters, and everything will update accordingly. So to begin with, we're going to do an unprotected section and see how that occurs. So you can see here, now for an unprotected section, you've got no plasterboard and you end up with 3 layers and 85 millimeters. All right, so this brings us to the new design factors. So the new char factors here, and you can always do more information. So gap, remember I mentioned before, that does influence your gap factor, and it gives you some guidance where you might actually have some sort of sealant to remove the gap altogether. But if you made that 1 millimeters and you solve for a gap, then your gap factor is going to reduce. K3 as well, you can see here that's a multiple factor that actually multiplies for the notional char rate and so forth. So you can always learn about the more information, and we are improving these now constantly, so you can actually learn exactly about everything when it comes to the fire design inputs. All right, so moving down, some of our inputs, we've got loading, superimposed dead load, and live load. Let's just do a 2 kPa SDL plus a 3 kPa live load. We're going to do extended gamma method for unsymmetrical sections and a 6 meter double span section. All right, so 0.7 unprotected, everything like that. All right, so what do we, yep, so 240. All right, so moving down, a few of the other inputs, you got the design factors as well, and that's based on your K factors in the code as well. So moving down, you can see here for our output summary, we are actually working right now at 92% and 28% loading. So if we go through calculation by calculation, Our charring factors, it's not a black box. It gives you very detailed understanding of the K factors, the gap factors, the initial lamination, the phases, the new charring rate in each phase, so phase 1, 3, and 4, and then the zero strength layer right now based on the draft Eurocode, and then multiply there to actually end up with your protection time, as well as getting to the design. So from that, you actually end up with what your end up design thickness is, as is indicated in the image. You recalculate the engineering properties based on the reduced section. You got your loading combinations as well, and then you got your analysis based on the two-span equal, and then finally the design code. So all of that actually behaving quite similar. So let's go back to our design. So right now, extended gamma method, 6 meters. If we go right now to a gap of say, let's say for our design, we're now at a 5 millimeter gap. What happens, you can see here now we've got the cross here. So we're right now bending in failure. So you can see right now, all of a sudden that's not working. So one of the most exciting things now from our perspective is you can now do a protected layer option. So for this, as I mentioned before, for protection on the underside, I just click protected. Now you have the ability to actually add protection. So let's go back to our webinar and do some examples. So let's just say on our hypothetical project, the acoustic engineer was exploring 2 options. One was a fully exposed where the acoustic option is on the top side, and the other one is a fully protected solution where the acoustic system is on the underside. So let's say we've already checked the top side or the top option. We're a fully exposed panel. But what about the second option where you've say got a plasterboard, a mineral wool, and then another plasterboard underneath that? So for this scenario, all you need to do is add different layers. So let's just add 1, add 2, and now you've got say 3 layers of plasterboard. That's actually protecting it right now. But for us, we can go to our mineral wool option. When mineral wool is selected, you can input the thickness of mineral wool. And you can see it working dynamically here. So right now, you can see that the plasterboard has protection, and then the mineral wool provides some protection as well for a certain calculated number of minutes, and then the plasterboard, and then it goes through there. So that's one option here. And in the calculations now, you can see in charring, you'll be able to inspect the calculations in detail here. And you'll be able to see the protection time. The plasterboard's 13 minutes, the mineral wool 6 minutes, and then the plasterboard's another 30 minutes all up. And then that's your overall protection time that's now available. So that's one option. And you can save that, and you can print the PDF and things like that. What about, let's do another scenario. Let's go unprotected. So it's going to update like this. So now we end up with an 85 millimeter, and we're failing again because we've lost the protection. Let's say if we maintain the glue line integrity, and I know for sure Timberlink has that, but speak to Timberlink, of course. And you can see that gives you a solid char rate as well. And now we're working again from a fire bending point of view. So very quickly, you can actually toggle options and scenarios from different options. So from a fire point of view, I skipped it, but let's just say if you did it, if it's failing now, it was failing at 139%, what do you do? Well, there's multiple options. You can control the gaps so that it was working when it had 1 millimeter gaps, reducing the char rate by 20%. Maybe there's a fire protection system you can input that lowers the cost of that. Another option is glue line integrity maintained. Some suppliers provide 2 options. They can charge more if you want a certain glue that maintains the glue line integrity. Option 3, you can say, if we do this acoustic option, we're going to protect our timber. It controls the fuel load, and we can work a 240 mil panel to work. Of course, you can upgrade the panel size, and a 260 mil panel worked here as well. So if you think about when it comes to cost optioneering, because one of our goals is to always reduce the cost, and good design at lower cost, which makes the timber option more beneficial, I guess, against the concrete option is always good. So, 3 options. 1 is acoustic protection. Number 2 is we can change our glues. Number 3 is we can do a thicker panel, all to achieve the 1 FRL that we're going for. And for some reason, I just screenshotted this and asked ChatGPT, if you had to choose between all 3 options, what would you choose as the cheapest? ChatGPT said adding the acoustic protection will be the cheapest out of all three, and the thicker panel of 20 mil is the highest expense. I probably think the opposite of what ChatGPT said. So it's interesting what that's coming up with when it and it obviously does it with absolute confidence. All right, so that's the CLT design. Next, we're going to do a single member design. So other thing here, when you hit save, we've got this new loading spinner now, which as well improves the loading of the app, which is something we worked for. So if we go back to the new calculator in our designs, so same for beams and columns. So let's say we're designing a column. Existing project, let's find the webinar we were just working on. And then you can add it to groups if you wanted to, but let's just do it a column design from a fire point of view. So for this in the webinar, we had a 648 kilonewtons for 5 levels of load and in dead, and a 720 kilonewtons with 2 beams connecting in it if you're talking about an internal column. So if we open up the column calculator we just loaded, so similar to before, you've got good dynamic imagery to know what the charring layer is from our cross-section. So this is a cross-section where both left and right face is exposed. In this scenario, you've got the new green ticks to see the different checks that are included. And then you've also got the elevations to see we're doing a 3 meter at these eccentricities and loads and everything like that. So for us, let's just say we're doing a 400 by 400 column in this instance. So next you got your analysis data. Let's just say we're doing a 3.5 meter floor to floor, so something quite big. Let's remove the lateral restraints. And then we go to the fire data. So similar to before, first input is the FRL. So let's make that 120 minutes. For width, faces exposed. Let's do both sides like it was on the other side. You can see you actually can add protection here as well, and codes do enable that. Let's just go unprotected. Unprotected, so all faces are unprotected. Design methodologies, let's keep it at AS1720, which we'll be using AS1720 part 4 as well. Input our load, so I think we had 648 and maybe 500. Forgive me if this, for the sake of not jumping between screens too much. Eccentricity, so this is from the axial load above. So let's just do depth of the column on 10, so 40 mil and 40 millimeters. And then next you can actually input the loading and eccentricity from the connecting beams, which adds more load and also a biaxial bending as well. So let's turn off the left and right beams and do top and bottom. And today we've got 50 kilonewtons and 50 kilonewtons, 200. So now the point of eccentricity is there. Go 50, 50. Let's just keep the eccentricity here for, well, now let's go like that, but you can play with the eccentricity to have more of an unbalanced mode, unbalanced load. So you can see we're failing right now. Input your design factors and then your checks as well. So the one thing I'll zoom in on here is the charring rate. So you have AS1720 part 4, like on the screens I mentioned before, your charring rate related to density for an unprotected timber as well. Design with the effective charring depth, and you can see here we're designing by a 240 by a 244. But if we did say change, for example, to our design codes to Eurocode, you've now got the Eurocode design method, which looks actually quite similar as well from a design perspective. Gives you a chart as well about how it's burning over time, and gives you the final cross section, which is 230 by 230. So a difference of 10 millimeters at the end of the day. So, and again, you can inspect the calculation. So you can see here we're failing now for lateral torsional stability. So with that, we can, provide lateral restraints. That'd be one option. Or of course, you just go a thicker member. You can change the grade as well. And lateral torsional stability is still not working. So anyway, in our own time, we can do it. But if you want to inspect the calculations, you'll be able to review that in design codes in detail. Actually, I know what's happened. Sorry, everyone. Yeah, it's probably because it might be because of a grade. Yeah, because we're using an Australian grade. that isn't compatible with Eurocode. Now it's working. So you can see here I just changed it to European grade as well. And this is the cross section we're designing with for a final design. We can hit save, and I'm keen for everyone to start populating your questions in the chat. Oh, sorry, where you do questions. You can hit print. This will take 10 seconds to do. So I'll just do it quickly, but you can see the design reports as well. Again, all detailed. You can see the clauses of everything and like that. So yeah, that'll take a few seconds to print. Just bear in mind that when you hit print, it takes about 15 seconds because it's populating all the data. So I'm about to wrap it up. So with that said, structural design, fire design, it's critical to scaling these buildings, and we need to understand them to be an enabler on projects. Timber behaves predictably in fire if you understand it in certain circumstances. Code compliance is evolving globally, some places faster than others. Fire engineering, it's a multidisciplinary game. I'd say first point it calls the fire engineer, but also the suppliers in knowing their own tested systems and the best way to design their products. And we're probably the best tooling for performance-based design. You could probably check your DTS design if there's span tables or anything like that, but you can always make sure that you actually are designing with the latest methods. So that said, thanks everyone for watching, and let's get into some questions.
Thank you, Adam, for that awesome presentation. So we encourage everyone to put any questions that you have about the presentation or the software or the new release into the question box now. We've got a few that have come through, 3 anonymous ones. So I'll spotlight the first one, Adam. Hi, do you also have anything for the fire design of connections? Is this something that CLT Toolbox is also working on?
Yeah, that's a great question. So we are right now, building the char modules like I showed you before as modules. So you'll see them in the first step integrated into our connection details. So, for example, like a beam to column connection, by the end of the year, you'll have charring around that. So, and then you'll be able to say input a protection system around that to protect the gap or something like that. But yeah, so that's coming. And then the other one over time is the exponential reduction method. We'd love to input from how your actual screw reduces its strength in the fire scenario. So it's a great question.
Awesome. We have another one here. Can you do acoustic build-ups for wall separating apartment rooms?
Yeah, we can. So that's a good question. I may just share my screen for this as well. So if you just give me a second, I'll give you a really quick version of the wall calculator. So it does perform quite similar to the floor calculator I mentioned, but whoops, let's go wall fire. But yes, when it comes to walls, there's other scenarios that occur, of course. One is you might have an internal load-bearing wall which isn't separating apartments, and if that's the case, you might have fire on both sides, or you might have something separating an apartment where it's fire on one side but an acoustic system and so forth. So you can see here it's a similar cross-section, but here you've got the time in minutes on the y-axis, and then you've got your final design layer here. So let's just keep it on manual input for the moment. But if you, similar to before, if you go, say, 60-minute FRL, that burns through. But for your protection, you can add layers. So let's just say if we're exposing both faces in this scenario, you've got a 3-layer panel with fire protection on both sides. So let's imagine if it's an internal wall with plasterboard on just one side, that might be the scenario. Or you can also then start adding more layers, and the drag and drop element here means you can just drag it to the other side as well with 15mm protection. And you might add another layer here, and again, similar to before, make that rock wool and say 50mm, and you can input the sizes there. So as you do that, you can see here the cross section available with fire on both sides, and we're just going to protect the right face and the left face. So when protection is selected on both, you can see the protection. We end up now with a 5-layer 105mm panel, or you can, so you'll be able to actually do it on both instances. And then, yeah, over time we can expand that out a little bit as well. So it's a great question.
We have two more awesome questions that have come through. One from Anonymous. Hey, Adam, there are some recent researches by Thomas Gurney that indicating timber elements could fail during the cooling phase of a fire. What's your thoughts on this from a compliance perspective? Has and will this be considered in CLT Toolbox?
It's a really good question. And I was waiting for it because there are some serious fire experts joining this webinar, so I was expecting some deeper questions. Hence, I opened the webinar by saying our green ticks are sometimes a relatively narrow scope compared to the broader range of fire engineering challenges. And as you said, during the cooling phase of a fire, elements may fail during them, but I'd imagine they'd only fail if the charring, if it actually gets to a certain point where you reduce cross-section is what fails. So if that's the case, I think our software is a tool that supports a part of that scope, but the part of, the actual dynamics of what happens during the cooling phase. And if it happens, I think the research was like well after 2 hours exposure. Like, I think that's just one of those areas for a project team to tackle in the context of whatever project they've got. But feel free, if you're anonymous right now, but feel free to share in chat your thoughts on that as well, if you've got any strong opinions for the good of everyone.
Awesome. And we have one from Andrew here. Can this calculator consider partial protection? Example, plasterboard protects ceiling but not walls, or partial the ceiling, partial the wall. How does the charring impact the fixing of plasterboard? Can it reduce integrity of the plasterboard? And he's clarified here, just on a comment to clarify further, I'm talking about the interface section between timber and plasterboard.
Gotcha. Yeah, so between the timber and if I hopefully understand your question well, Andrew, I think feel free to send me an email if not, but by partial protection, are you meaning like it's protected in one area and not? Or if you've got a ceiling exposed and a wall not exposed, like our platform, you can do calculator by calculator. So it'd be one scenario and by scenario. So you do this floor and the wall separately. But yeah, so the actual fixings as well is really important to actually get right, to make sure that the actual connection of the plasterboard to the CLT does provide the full protection time that's calculated as well. So that's another one of those things. But I'm sure, Andrew, I didn't quite how does the charring impact? Maybe, Andrew, if you like, feel free to hit me up on LinkedIn or something, and I might try and answer it correctly if I didn't. How does the fixing? So yeah, fixing the plasterboard. Yeah, so I reckon just the fire tests and the fire tested systems of fixing. So I think the Wood Solutions design guide does cover the fixings a little bit. So there are different guides out there which looks at the fixings in general to make sure it's covered.
Awesome. If there's no further questions, we just have.
Are you with me, Corey?
No. Yeah, you're still there. Can you hear me?
I can hear you.
Yeah, we can hear you. So if there's no more questions, we've just got a few slides to wrap up today, because we wanted to share that if you liked what you saw and you're interested in trialing these calculators, for the month of May, we're going to do a pro trial, so you get access to the fire calculators. So if you are interested, we encourage you to get in touch with myself directly. So corey.jones@clttoolbox.com. How this will work, we'll jump on a quick call, a 30-minute call to give you access to the software, free access to the software for 30 days. And we'll also show you through some calculators that are relevant and relative to the work that any projects you're working on currently. So you'll then have 30 days access. While you have the access, you'll have an abundance of technical support, both from our team here in Melbourne, but also our product management team over in Serbia. And at the end of your 30 days, we'll offer you a discounted licensing offer as well. So get in touch if you are interested. As well, I just wanted to mention that our next webinar is going to be on the 11th of June. It's a CLT shear wall design webinar. We'll be covering designing CLT shear walls. We'll be also covering the new bracket modules that will be released between now and then, and updates and design with the CLT shear wall. So we're really appreciative of everyone being here today, and we hope to see you all at the next webinar. And thank you, Adam, for the awesome presentation, and thank you everyone for the incredible questions. So have an awesome day and see you then.